Hi guys, we're going to be talking about section 12.6 today on the unit circle. We did a paper plate of the unit circle, and you can use that or build it off of the unit circle by drawing triangles on it. The unit circle is a circle with a radius of 1 unit, and it's centered at the origin on the coordinate plane. You can use a point, any point called P, on the unit circle to generalize sine and cosine functions. For example, if we just pick this random point, we're going to call it point P, it has the coordinates of x, y. When you build a triangle to go to that point, you would go x units to the right, y units up, or you would go directly to it with the radius of r. In this case, r is 1 because it's a unit circle. So when you think of your SOHCAHTOA and think of sine of an angle, so if we're looking at this angle at the origin, and based off of that angle in SOHCAHTOA, it would be opposite over hypotenuse, which would be y over r. In this case, r is 1. So the value of the sine function of any angle measure on a unit circle is always the y-coordinate at that point. The same can be based off upon the cosine function. Cosine in this triangle is adjacent over hypotenuse, would be x over r. R again is 1 in a unit circle. So the cosine values are the x-coordinate in a circle. So if you wanted to find out what x is equal to, that's the cosine of the angle measure, and the y value is the sine of the angle measure. So both cosine and sine functions of theta, because they're defined using the unit circle, they are called circular functions. So if we want to find the exact values of any point on the circle, you can look at the coordinate of the point at that value of the angle measure. For example, if you plot the coordinate at 45 degrees, you would rotate around the circle and put it here. The value of that can be based off a triangle that you build, or if you know it off of the unit circle. Try to think of them without having to look at your paper plates all the time. Try to build it in things that you know. For example, in the unit circle, if this is 1, this is a 45, 45, 90 triangle. The two values on your legs are square root of 2, square root of 2. So if you're building your coordinate point there, it is square root of 2 over 2 and square root of 2 over 2. The value of the sine function is the y-coordinate of that point, which is square root of 2 over 2. Cosine of negative 210 degrees goes in the negative direction around your circle until you hit into the second quadrant. The reference angle at that point, how many degrees you went past the 180 degree line, is 30 degrees. That means you're looking at a little 30, 60, 90 triangle. Across from the 30 in the unit circle, the radius is 1. Across from the 30 would be half of that, which is 1/2. And across from the 60 degree angle, across the x-axis, is square root of 3 over 2. That means the value of this point went left by the square root of 3 over 2, which is negative, and up by 1/2. The cosine value is going to be the x-coordinate of that point, which is negative square root of 3 over 2. Okay, if you want to try the next couple without me saying anything, hit pause and then come back and see if you match my answer. So if we're doing cosine of 4 pi over 3, that is a radian unit this time. When you circle around for a 4 pi over 3 angle measure, you're going to land in the third quadrant. This reference angle is pi over 3. That's like a 60 degree reference angle at the origin. That means the coordinate of the point across from the 30 degrees is 1/2 in the x direction. Across from the 60 degrees, or the pi over 3, is square root of 3 over 2. So the coordinate of the point goes left by 1/2 and down by square root of 3 over 2. That value of the x for the cosine is negative 1/2. Again, if you want to hit pause, try the next one on your own, and then catch up to me after you hit play again to see if you're right. If you're at 13 pi over 4, that means you've actually looped the circle. If you go all the way around the circle, that's 2 pi. If you put that in terms of 4 in the denominator, that's 8 pi over 4. If you go another pi, that would be another 4 pi over 4. That would put you at 12 pi over 4. This 13 pi over 4 actually goes one more pi over 4 halfway into the third quadrant. That is a pi over 4 angle measures in this right triangle. That means it's like a 45, 45, 90. The side lengths are going to be, radius is 1, and then each of the legs is square root of 2 over 2. Which means the coordinate of this point is square root of 2 over 2. in the negative direction, and then negative square root of 2 over 2 for the y value, and the sine value is going to be the y coordinate, which is negative square root of 2 over 2. Okay, if we keep going, all of these I would suggest you try them on your own first, hit pause, and then catch up with me and see if you actually get the same answer. Try not to look at your paper plate, and if you do, then come back and try to do it on your own first and then look at your paper plate. So if you're looking at a 60-degree angle, you turn into the first quadrant. This is a 30, 60, 90 triangle. If you label the parts on the triangle, you're going right by 1/2, up by square root of 3 over 2, and then your coordinate is 1/2 square root of 3 over 2. The y coordinate of sine is then the value of sine of 60, which is square root of 3 over 2. Cosine of 3 pi over 4. 3 pi over 4 lands in the second quadrant, halfway. That's a 45, 45, 90 triangle. So each of the side lengths is square root of 2 over 2 for your unit circle. That means the coordinate of this point is a negative square root of 2 over 2 and then a positive square root of 2 over 2. That means the coordinate, or the value of cosine of 3 pi over 4 is the x coordinate, which is negative square root of 2 over 2. Cosine of negative 120, you're going in the negative direction, and you are in the third quadrant. If you build your triangle off of that, negative 120 is 60 degrees away from being at the 180, so this is a 30, 60, 90 triangle. At 60 degrees, opposite that is going to be your square root of 3 over 2. Opposite of the 30 is going to be on your x, which is 1/2. So the coordinate of this point goes left by 1/2 and down by square root of 3 over 2, which means the cosine, the x value of that coordinate point, is negative 1/2. If we switch over to radians, the radian value, cosine of pi over 2, cosine of pi over 2 is going to be at the 90-degree mark. If you put a coordinate of a point there, that is at 0, 1. It doesn't actually build a triangle. You're just looking at the x coordinate of that point, which is 0. Sine of negative 135 degrees is going in the negative direction 2 quadrants later. That builds a 45, 45, 90 triangle. So you would go left by square root of 2 over 2 and down by square root of 2 over 2. The sine value is the y coordinate of that point, which is negative square root of 2 over 2. Sine of 690 degrees, you have looped the circle. So if you go 360 plus another 330, you've gone 690 degrees. That means you are 30 degrees shy of completing the circle. That means you're looking at a 30, 60, 90 triangle. Across from the 30 is 1/2. Across from the 60 is the square root of 3 over 2. So you're looking at the y coordinate of this point. It goes positive square root of 3 over 2, negative 1/2. The sine of sine of positive 690 degrees is equal to negative 1/2. Okay, I would suggest you try the rest of these on your own, and then you can check with a friend to see if you're coming up with the same answers, or you can hit pause right now, and then I will just write the answers. So hit pause, do all of them, and then play again and check your answers. The answer to this one is negative 1. Sine of negative 5 pi is 0. Cosine of 8 pi over 3 is equal to negative 1/2. Sine of 1035 degrees is negative square root of 2 over 2. Sine of negative 17 pi over 4 is negative square root of 2 over 2. Cosine of 1290 is negative square root of 3 over 2. Number 13 is negative 1/2. Number 14 is square root of 3 over 2. And number 15 is negative square root of 3 over 2. Check your answers, and I will see you again in class tomorrow.